Welcome to 3 Steps to Sketch. Today we're going to graph a basic unshifted cosecant graph, y equals cosecant of 4x. So here's our template to keep everything organized, and here's a grid. And looking at the equation, we know that we should be using the basic unshifted cosecant template because our equation is in the form y equals a cosecant bx. We see that there are no shifting terms going on with our equation. So now we can jump in to step 1. Let's find our companion equation and the essential information that goes with it. So the companion equation for a cosecant graph is simply going to be its reciprocal, sine. So we're going to graph y equals, replace cosecant with sine, y equals sine 4x. So if we can graph this, in step 3, we'll take the reciprocal and get the graph that we actually want, cosecant. So if you don't know how to graph basic sine graphs yet, be sure to go into the video links in the description and watch that video first, master graphing sine, and then it'll be so easy to transition into cosecant graphs. All right, so let's get some information on y equals sine 4x. A is going to be the leading coefficient and understood 1. That's our amplitude, or the distance from midline to maximum or midline to minimum, and that's going to help us set those points. Okay, B is the coefficient of x, and it's 4. So we know a couple things from B. First, we know that 4 cycles should happen between 0 and 2 pi, and that'll be true for our sine companion graph as well as our final cosecant graph. Another thing it tells us, or helps us find, is the period. So calculate the period using 2 pi over b. So we have 2 pi divided by 4, which simplifies to pi over 2. So our period, or the length of one horizontal cycle, is going to be pi over 2. So now that we have that information for our base companion graph, we can choose scale labels. And we're going to do this really intentionally for our horizontal scale. We're going to take our period and divide it by 4. So if we take pi over 2 and we divide by 4, or we multiply times 1/4, we see we should count by pi over 8 as we label our horizontal axis. And this ensures that each of our starting points, our companion pattern points, will align nicely with our horizontal tick marks. And that just makes for a nice clean graph, and it helps us ensure accuracy. So we've got our horizontal scale. The vertical scale, 1 usually works really well. And it will in this case. Usually look to A to help determine that. All right, so let's take a minute to go ahead and label our axes. So starting with the horizontal axis, let's count by pi over 8. So we have 1 pi over 8, 2 pi over 8 reduces to pi over 4, 3 pi over 8, 4 pi over 8 reduces to pi over 2. And at this 4th horizontal tick mark to the right, we should have gotten the period. So we said that was the length of a cycle. We have 4 key points in the cycle, and then it'll repeat. So that's a nice way to double check that everything's going to work together. All right, so then we have, continuing, 5 pi over 8, 6 pi over 8 reduces to 3 pi over 4. We have 7 pi over 8, and 8 pi over 8 reduces to pi. So if you're following along, pause now. I'm going to pause and label the negative side of this axis. Okay, so there we have it. So all the same values as before, just with negative signs. And let's label our vertical axis counting by ones. So we have 1, 2, 3, -1, -2, -3. So now we have everything we need to get this companion pattern graphed. That'll be step 2. But before we go from step 1, which is really our analysis and organization step, let's find the asymptotes equation for our cosecant graph. So there's a really easy way to do this. I won't go into too much detail about that now. I will post some separate videos that really delve into this topic and work with some more advanced equations. But all we have to do to find the asymptotes equation is take the inputs of cosecant. Okay, so I'm going to do a little scratch work here. We take 4x and set it equal to where the original x-intercepts of sine happen. And we do this because if we have x-intercepts or zeros and we try to take the reciprocal, so when we get to our cosecant graph, 1 over 0 is undefined, and that determines that we have a vertical asymptote. Okay, so that's why we're doing this. A little bit of a tangent there, but just a background as to why we're doing this. So we know that the zeros of y equals sine x happen at 0 plus pi k. So we set these two things equal to each other. The inputs of the cosecant function equal to 0 plus pi k. And here k is an integer. And depending on what integer you substitute into the equation when you have it finished, you'll generate a particular vertical asymptote. All right, so let's get x equals here, divide the whole equation by 4. So our asymptotes equation will be x equals 0 divided by 4, of course, is 0. And then we have plus pi over 4k. So like I was saying, as you substitute in different values for k, you'll get different asymptotes. So running through a few, if you let k equal 0, we should have a vertical asymptote on our final graph at x equals 0, or on the y-axis. You let k equal 1, simplify, we see we should have another at pi over 4. If k is negative 1, we should have one at negative pi over 4, and so on. So it's a really neat and efficient way to represent all of the asymptotes of our graph. All right, so now that we have all of our analysis done, we can move to step 2, where we're going to plot our companion pattern. So basically we're graphing y equals sine 4x. Do this lightly or in a different color because this won't be our final graph, of course, it's our companion. Remember that the sine pattern that's unreflected, meaning no negative out front, is going to be starting at the origin with an x-intercept, then a maximum, another x-intercept, a minimum. So we'll do that now. We have our 0 here at the origin. At the first horizontal tick mark moving to the right, we'll have a maximum, and to get the y-coordinate, simply look at a. So it'll happen at pi over 8, 1. Then at the next horizontal tick mark, we'll have another x-intercept. And the third horizontal tick mark, still moving right, we will have our minimum. And to get the y-coordinate there, just take the opposite value of a. All right, and then we'd come back, an x-intercept, we'll start the pattern all over again, and you see that we have a really nice sine graph here. So I'm just sketching it in to show you. You don't really even need to sketch it in. But this is graphing y equals sine 4x. Now that we have this companion graph, we're ready to move to the fun part, step 3, where we recip, sketch, and repeat. Once you've done a few cosecant graphs, you'll just know what this graph should look like, but we will go through and just choose a couple of special values to talk about the reciprocals, and we will take those and plot those points. So starting at the origin, if you try to take the reciprocal of 0, we talked about that earlier, you have 1 over 0, which is undefined, and we have that vertical asymptote at x equals 0. And that's when k is equal to 0 for that asymptotes equation, if you're tracking that. And now we can move on. Let's say, so we're moving to the right along our companion graph, and we're just taking the y values and we're flipping them, or taking the reciprocal. So if we take 1/2, just choosing a nice easy one, the reciprocal of 1/2 is 2. So let's plot a point. Moving the reciprocal of 1 is just 1. The reciprocal of another 1/2, as we keep moving right, is going to be 2 again. So you kind of see that first cosecant curve forming. As we get to pi over 4, that's another x-intercept, so we have a vertical asymptote there. That's when k is 1 in that asymptotes equation. And taking reciprocals for a few more values, let's do negative 1/2 becomes negative 2. Negative 1 is negative 1. Another negative 1/2 is negative 2. All right. And then you'd have another vertical asymptote as you hit that third 0 in line, that pi over 2. But that'll be the first part of another cycle. So we'll stop right here and go ahead and sketch. So we're sketching in this cosecant curve. We have it just like that. Notice how we have some special terminology for these points. So this point right here is what's called a local or relative minimum. And it just means in that general area, it's the lowest point. It's not the absolute minimum. Of course, there are y values much lower than that as we move on to the right. But in the general area, this is the lowest y value. So we call it a local or relative minimum. And notice that came from the maximum of the companion sine graph. All right, then this point, similarly named, is a local or relative maximum, just meaning in the general area, based on what's around it, it's the highest point in this area. Not the absolute, but the local or relative maximum. And it happens where our original companion equation had a minimum. So now we can repeat for several cycles. So we know we have an asymptote here at pi over 2. That's when k is 2 in that asymptotes equation. Hopefully you're tracking. And we'll just plot the local minimum here. We know what this graph is supposed to look like. Okay, so we have that curve here. We have another vertical asymptote at 3 pi over 4. That's if you let k equal 3. Another curve that has that local maximum. And at pi, that's when k is 4 in the asymptotes equation, you have another vertical asymptote. All right, so let's repeat this pattern in the other direction. We'll go a little quicker, and we're just working backward here. So we have a curve with a local maximum, the vertical asymptote that comes from when k is -1, the local minimum curve, another vertical asymptote at negative pi over 2, that's when k is equal to 2, a local maximum curve, the asymptote that comes when you let k equal -3, and our final curve here, asymptote at negative pi happens when you let k be -4. So this is 4 cycles of y equals cosecant 4x using the 3 steps to sketch basic method. Again, this is for unshifted cosecant graphs. We'll have another method later on that deals with the more advanced shifted cosecant graphs. But you've got a really nice graph here. So if you want to see any other worked examples, I'll post some links in the video description, and I'll also post links for graphing some other trig functions as well. So thanks for watching, and good luck with your graphing.